And we are live on YouTube. Welcome to our KubeCon special edition of the HashiCorp Terraform Community Office Hours. I'm your host, Kerim Satirli. My co-host today is Tracy P. Holmes, and we're joined today by Phil Sautter, Product Manager for the Terraform ecosystem. If you have any questions or comments, we'd love for you to interact with us via the chat. Feel free to tweet us. We'll get to those a little bit later. But as you do, please keep in mind both the KubeCon and our code of conduct in this virtual space. In general, the rules are pretty simple. Be welcoming, inclusive, friendly, and patient. Be considerate, be respectful, and be professional. You can review our code of conduct at hashicorp.com/community-guidelines, and we'll have a link for that in the chat as well. And with that, let's get started.
Before we get started, our chat is currently disabled. I know you all are ready to jump in and say things. Give us just a few seconds and you'll be able to ask Phil all of the questions that you would ever want to ask, including what's his favorite color. Thank you.
Very nice. Thank you for fixing that. While we get set up with the technical stuff, let me give you a quick overview of what we'll be showing today. So we'll start out by first finding our editor, which is always the hardest part. And then we'll show you how to do things in the Terraform Kube provider, the generic provider. We'll look at the AlphaProvider, and if we have time, which I'm not sure because it's a pretty packed session, we'll talk a little bit about the Terraform operator for Kubernetes. So there we go. You all should be seeing my screen right now, or at least my editor. All right, awesome. So to give you a basic overview, we're looking at three simple resources today. Namespaces, which we're all familiar with, deployments, and a service. And so the thing you're seeing right now, standard YAML, we're all pretty familiar with. If you use Kube a lot, then this should be essentially second nature. So YAML is a great way of doing this, but we like doing things in Terraform because it gives us a single language, in HCL with Terraform, because it gives us a single language to talk to all the tools that we like to use. So let me show you how to do this thing in HCL and in Terraform. And if you want to follow along, we'll share a link with you in the chat for a repository where we have all of this built for you. So let's start by defining our base code. In Terraform, you have a system called providers, which abstracts away API interactions, which then allow you to use code to describe your infrastructure. This process is called infrastructure as code, and codification is beautiful because it means rather than clicking in a UI, you do everything through your editor. So we'll start by defining the Kubernetes provider, 113.3 right now, which I believe is the latest edition. And we're loading our local config file just for ease of use. Now, as you go through the demo, you'll notice that we haven't done anything with GKE or AWS or Azure or any of the other public managed Kubernetes environments, for the simple reason that it's hard to predict which cloud is your favorite. We all have one. Can see people smiling there in the background. But the important thing is the operations we're showing you today will work on any Kube environment, as long as you don't host it, which we've definitely done while building the demo. So with that in mind, we've defined a provider. Let's start by setting up a namespace. And all that takes is 5 lines of code. And the one thing we're doing here is actually defining a variable for it, because it allows us to reuse the content of this. And you can see the default value for this is beacon, which is our demo app for today. And with that, it's very straightforward. We're a couple of minutes in and we've got our namespace. And let's see how we can actually get that to work. And just checking with the editor showing more code right now. Are we still good with font sizing and everything? Awesome. So we've got our beacon application and we'd like to deploy that on 3 replicas. And again, we're using a couple of variables here just for ease of use. We don't like to repeat ourselves. And more importantly, I very much like to make sure that all this stuff is consistent. So variables definitely help a lot. And we'll share a couple of links in the repository we have where we discuss how Terraform variables work, what options you have. But before we dive too deep into that, let's actually have a quick look. So we defined the namespace early on and the application name. You'll notice both of these are actually the same. That's useful for this demo, but might not always be the case. We're defining a default value, but I could also omit this value. And then Terraform would ask me on runtime what the value is that I want to use. So going back to our code, if we have a look at our template, we're defining a label, again through a variable. And further down, we're actually defining the workload we want to run the container, which is my colleague Taylor's beacon application. And beacon is essentially an Nginx container that auto refreshes and prints out the environment. And we'll get to that in a second. But before we do so, let's have a look at the service, which is the final part. And let's make this a little bit bigger. So you'll see we're defining a Kubernetes service. We're using the same variables before. For namespace, we're now actually not using the variable anymore, but a dynamic reference, which makes this even more interesting. Because in here, rather than saying this should be beacon, which would mean that if we change the namespace and forget to update this part, we now have dynamic references. So any change in the top level namespace flows all the way down to the Kubernetes service. Same holds true for the selector. And then we continue on with a few more variables and we're good. And so let me just change into this directory for you. And if we do a plan, we can actually see the service is already running, which is always nice. Let's remove everything. We actually do test our demos before we run them, which is very important.
Don't tease the viewers like that.
And while we wait for the destroy to happen, which shouldn't actually be that long, there we go. We'll go through the standard Terraform lifecycle. So generally, you want to start out by writing your resources, which we've done in these files, or if you just copy or fork this repository, then you don't have to write them. Save yourself some time, enjoy more KubeCon. Then we run a plan, which is essentially us saying, hey, Terraform, this is what I would like to do. How does that look? And Terraform then outputs a whole slew of information telling you which values are already known, which values will be known after the apply, and so on. And you'll notice there's a lot of information happening here, maybe even information overload. We only have 3 resources, yet we're looking at a couple hundred lines of output. That's all going away. Terraform 0.14 is coming, where this will be a lot cleaner, at least from the second apply on. So I already know that this all looks good. So we're not going to go through line by line. And we'll do an apply. And just to be sure, because we didn't create an execution plan, we just looked at one. Terraform actually makes us verify that everything looks good. We live dangerously, so we'll just do yes. And because I'm running everything on a local cluster, the whole operation is done in 4 seconds. And that's beautiful because now on port, I believe 8081 or 8080, there we go, 8080, we have Beacon running. And let me see if I can. Oh, wait, of course, I'm sharing my editor. So you'll have to take my word for it that this is actually running on localhost. Well, technically in my local kube cluster. And we've got a working application. And yes, this is without a doubt the simplest possible application that you can envision. And that's okay, because that's how you should and would want to start with your Terraform usage. Start simple, build up from there. And in the meantime, have we already got some chat interactions going?
Not yet. I think everybody's drinking coffee kind of like I am right now.
I mean, that's definitely a good start of the morning.
It is, but we'll take non-coffee supported questions also. Those are the interesting ones.
Those are definitely the interesting ones. So let's see. So before we jump into the AlphaProvider, which is actually a little bit more interesting, also a little bit more dangerous, let's do a quick review. Terraform has a principle called providers, and those abstract away API interactions. What we're doing here is defining everything as code, but what Terraform then does is just translate this into API calls to the Kubernetes cluster or clusters, depending on where you run it. This could be local, this could be on your Raspberry Pi, which is probably the preferred way of running Kubernetes these days, or GKE, AWS, anywhere you want. So we've got this defined here, and this all looks good. And it's pretty much the same thing we've defined in YAML. Code-wise, there's not a lot of difference, with the main benefit being that a lot of these strings you define here actually become variables. And you might type a few characters more while you're setting this up initially, but down the road, it pays off when you only have to change a single variable in your variables file and go from there. Any Terraform apply will make sure that whatever you define here, your desired state, will actually be applied here. And that's beautiful. So switching gears a little from the Kubernetes provider to the AlphaProvider. And again, if you're cloning this repository, everything is there for you. All you need is a moderately recent version of Terraform. I recommend 0.13.5 or 0.14 for extra fun. Let's have a look at this one. So as before, we're defining a provider. In this case, we're using the AlphaProvider. And we're defining a couple of variables here. Again, we're loading our local kube config because that's what we want to work with. And we're defining a manifest. And if you compare these two next to one another, which I'm going to do in a second. There we go. Now, if you remember earlier on, we looked at the Kubernetes provider, where we have specific resources for everything that Kube supports, or for many things, I should say. So we've got a specific namespace resource where we define the name, and we can define a couple of other variables. With the AlphaProvider, the primary resource is your Kubernetes manifest. So if you have YAML that you want to convert to HCL, this is a pretty interesting approach. And so, Phil, you work on the AlphaProvider. Well, you ensure that the AlphaProvider gets built, we should say, which is the same as working on it. Can you help our viewers understand what's the impetus behind building the provider?
Yeah, so there's really, there's in Kubernetes, when you're interacting with Kubernetes through the API, right? The standard resources that are in Kubernetes have a well-known and well-defined schema, which matches very well with the way Terraform works with our resources. But as custom resources came into view and into prevalence, we really had no good way of interacting with these sort of dynamically defined schemas for the custom resources that you could create. And also there were other extensions that were being added to Kubernetes like Knative or KubeVirt that differentiated from the way a traditional resource was implemented. And so we had to go out and create an operator that could, a provider that could accommodate this dynamic schema. And we did that, by actually doing validation against the Kube API before we do the apply to match the resources that you've defined with the schema that's available in the Kube API.
This is definitely an interesting approach because it allows you to, as far as I see it, it allows you to hit the ground running a lot faster. You don't have to wait for Terraform to support a specific resource that wasn't there right away. You don't have to necessarily wait for a specific PR to be merged. If you can define it as manifest, you're pretty much good to go. Now, of course, the question is, how do you go from YAML to describing it in Terraform code in HCL, so the HashiCorp configuration language? And that's an interesting question. There's a couple of nice tools around this. Probably the easiest one, if you have Terraform installed, is to just take the Terraform Console. And so we'll go into the YAML folder. And in here, you can tell typing is really hard when there's a microphone covering half your screen. We'll use this beautiful one-liner where we YAML code the file namespace YAML and then have that rendered through the Terraform console. And we get the output that's actually Terraform compatible, which is this. And if we go into our namespace, you can actually see that these two would essentially be the same, with the difference being that we changed the metadata name. So let's see. If we go to a couple more involved resources here, and just to be clear, the AlphaProvider has a lot of power. But we all learned that with a lot of power comes great responsibility. So be sure to read the README. And just to make sure you don't hose your cluster, I'll warn you here, the AlphaProvider is currently in experimental status. We do not recommend you use it for production. But if you do and everything blows up, please send us your dev log and crash log, because we're very curious about learning from that. And we'll have a link for that. Actually, the last link we shared on there is an issues tab where you can report any issues you might have.
Don't smile when you say that. You can't say, hey, we recommend that you don't use this in production, non-caffeinated viewers. However, if you just happen to use this in production, make sure you send us the logs. You couldn't even do that with a straight face.
I love that kind of feedback. I mean, it is the best, right? This is like the perfect Friday project, right? Like KubeCon is done and you're like, hey, you know what? I should try out all these new versions and, see what your Raspberry Pi can do. run Kube on there. It's always fun, very rewarding too. I mean, in general, it's fun to run stuff on Raspberry Pis.
Yep.
And then try out the provider or run it locally. Docker Desktop now supports, well, has supported Kube built in for a while. There's many great options. And this is a lot of fun to do. So let's see. And as we wait for some questions, just a reminder, our code of conduct is in effect, but that doesn't mean you don't have to ask questions, and you shouldn't ask questions. You should definitely ask questions because that helps us help you learn more. So if we're switching to another approach, let's say you don't want to create resources with Terraform, but you definitely do need some input from your Kube server. Or technically, you need your Kube cluster to report some data to you that you can then use in Terraform. We could have a look at some data sources. So we'll start here with the Kubernetes service data source. And let me just switch directories there. And this is an interesting approach, I think. What we're doing here is we establish a connection with our cluster, just as we did before. We load our local config file, so our host, client certificate, and everything else that we need for auth, if enabled, is provided. And we create a data source. And when you think of API interactions, this is essentially a GET. So we're getting data, we're not changing anything, and we're specifically querying the services for the beacon service, which we've defined in var application name, which happens to be beacon, and a namespace name, which also happens to be beacon. And so if we run this here, we can see that there's a couple of outputs that have been predefined by us. So let's have a look at how this looks like. I'm going to make my screen a little bigger in the hopes that the whole line actually fits. And let's go. So what we're doing here is we're consuming some data from the Kubernetes service data source. We're targeting the load balancer ingress, and specifically the host name, and we're targeting the spec to get the port. And the reason for this is pretty straightforward. As you can see here, what I was actually curious is under which host name and under which port is my application running. And of course, we can predict with a single application that it's localhost and 8080. But now imagine this is running on a different part of your network, not localhost. Maybe it's running remotely. Maybe you're not assigning the port to 8080 all the time. By using these variable references, we're able to get the data that we need and then define it in ways that Terraform can output them. Now, this has a couple of utilities. For advanced Terraform usage, you could use those outputs in modules. So modules that allow you to read Kube resources, in this case, service, and make those items like this available to anything else that you want to do with Terraform. You could be writing it to a SQL database. We now have a plugin for that for a couple days. You could be generating template files. On the other side, maybe you don't want to be writing your crawl calls manually. You'd rather Terraform generates those for you. That's also possible. Using template file or something else, you could essentially say, get those URLs for me, including the ports, build the curl call around that you need, and you can have your QA tooling automatically load newly deployed applications. So let's have a look at what we can do here.
I've also got some good questions lined up whenever you get a chance.
Oh, awesome. Give me a sec. So before we jump into the questions, let me just show you one of the cool features of Terraform that most people don't get to use a lot because it's not the standard workflow, but it's super easy for debugging. Terraform Console. In here, you have access to a neatly rendered version of your Terraform state, but you can also carry out any operations. We used the YAML decode option earlier, the function, but you could also echo random content, or in our case, we're actually printing out the contents of the Kubernetes service data source. And so in here, I have all the addressable line items that we need, including my cluster IP, the ports, which we've seen earlier, and pretty much everything else. So with this, I have all the information and insights that we need for rendering the outputs we talked about. So when you start experimenting with the Kubernetes providers or any other provider, use the console to see what's actually in your variables. What do your data sources report back? Because this is a very fun way to explore. And with that, let's have a quick look at questions.
You ready for the first one?
Yes, ma'am.
This is for both of you, either of you. The first one is, what are some patterns you use for creating and managing namespaces with the existing provider? Also, how do you handle existing namespaces like kubesystem and creating resources using Terraform into those?
You want to go first, Phil?
Sure. Yeah. So for existing resources, and this would be any resource really, not just exclusive to namespaces, we have this command called Terraform import. And the way that works is you describe in HCL the way you would a new resource that matches the existing resource. And then you use the Terraform import command to import that resource into the state. And then you can manage it as you would any other resource. And we also have a resource for leveraging the default namespace in a Kubernetes provider. And then patterns for naming. I think that's really up to you and your organization, right? Kubernetes certainly has some constraints around like lengths and characters, but namespaces, like any other naming convention, is significant to you and the people who use it. So that would be my non-prescriptive recommendation there. Kerim, do you have anything to add there?
Yeah, I think with naming, I always feel like the answer is it depends, right? It depends on your team. It depends on the environments you have. It depends on not just the production and application environment, but it depends on almost the social environment your company operates in. Maybe you need to have, a dozen different environments before anything can hit what is traditionally considered production. Maybe those names need to be reflected in your namespace. It's really hard to prescribe this is a perfect naming convention because, as with the standards, everyone will eventually come up with their own and go from there. I think the only advice I have for naming things is use underscores, not hyphens, and go from there.
Cool. All right. The next one is, you're a Terraform noob. It's okay. Can you talk about the data keyword a little bit? I'm a Terraform noob.
Absolutely. First of all, if you're new to Terraform, make sure to check out learn.hashicorp.com/Terraform or any of our other products on there. We currently have upwards of 400 tutorials that can help you essentially from your first day of Terraform to, getting certified. So there's definitely a good learning path there. One of the tutorials there will talk about the data sources, which is, when that was added a couple of years ago, it was such a game changer. Up until that point, Terraform used to be a write-only tool. Well, write and update. And if you're thinking of CRUD, then it would be essentially the CUD. But reading was always a lot harder. You could use resources, but only if you imported them, as Phil mentioned. With data, you pretty much get access to all the same data without importing it into Terraform right away, which makes it a lot easier to consume. And then because Terraform has a lot of really, really good functions, you can output that data in any other way. So if you're new to Terraform, let's say you're currently doing everything with Ansible, and you want to read some of these things from Terraform and get them into Ansible, you could use data sources and then Terraform outputs to generate consumable information and go from there.
Nice. You got to follow up on that one, Phil?
No, I think that was spot on. That's fantastic.
Cool. And then the last one for right now is, hi there, I would like to know the way of installing Istio Kubeflow into Kubernetes with Terraform.
I feel like I've seen this question before. I don't think we have a prescribed way specific to those tools, but let me see if we can actually find the...
I've got a link to it.
Awesome, thank you.
I think Phil might actually have an answer for this one, and I'll see if I can grab that. So for the viewers, this was asked in our KubeCon Slack, which you absolutely come join us in our KubeCon Slack, and answered, but I think Phil has an answer for this as well.
Yeah, so I have kind of a definitive answer to this question, which I'll get to in just a moment, but more of like a conceptual answer as well, which is, if I'm looking for something and I want to know if it's Terraform supported, like where can I go to find that information? And the answer to that is the Terraform Registry. So we have a registry, a public registry of both providers, which like the Kubernetes Provider and the Kubernetes AlphaProvider, actually perform some integration, and then modules. And Terraform modules are an encapsulation of Terraform code that does something with one or more of the providers. And so, you can go on the Terraform registry and you can search for Istio, or you can search for Kubeflow, and you can see if there are either providers or modules out there for those things. And I do believe with Kubeflow, we do have at least one module that I'm sure will be linked. When it comes to Istio, so Istio actually uses a binary, they use Istio Cuddle. So I don't believe there is a solution for that today, at least a well-defined solution. So that would really necessitate somebody creating an Istio provider that uses the Istio Cuddle logic. But there are ways to break out of Terraform and execute local commands as well, if that's part of your workflow, though generally not recommended. Tracy, it looks like you had something to say.
I do, because you ran right into my plug for tomorrow. For those of you that would be interested in creating a provider for that, I'll be talking with the plugin SDK team about provider development tomorrow on HashiCorp Live, and I'm learning that one as well. So please come join me and ask all the questions, because it's going to be really, really interesting.
And I think you would actually be surprised at how easy it can be to create a provider with Terraform. So I would, if you're at all interested in that, I would highly recommend it.
Yeah, I'm excited about seeing that one. I think for me, being in Europe, it's also pretty cool because it's at the end of the day, so I get to enjoy, like laid back session, learn something new. It's pretty good into a week of conferencing, virtual as it may be. And just switching back to what Phil was talking about, the registry. The registry is part of the Terraform ecosystem, and we'll have a little overview for you in our chat of a couple of the things that you can do with the registry. But in essence, we have 500 plus providers in there. I think I was going to say 5,000 modules because that's what I have in my head, but sadly it is only 4,375. So if we could make this 5,000, I know the registry team would definitely be grateful if that could happen before the 31st of December. So get cracking. In here, you can find all the resources that we've been talking about. We've got links for that in the repository, so you don't have to actually screenshot my browser URL bar, but you're welcome to. And in here, you can also find the documentation you need, a quick getting started code snippet on how to use the provider. Note that we're currently always suggesting the latest version in the version pinned format. That's nice because code that works today will work tomorrow and will work 6 months from now, unless your kube cluster completely changes. And so with that, we've got pretty much all the resources in here with definitions, with code that allows you to just try a couple of things out. And as always, if you find any issues with that, click the report an issue button. If you see documentation problems, feel free to hop in and suggest a change. Open source contributions. I know Tracy has strong feelings about that. Open source contribution is not just being able to write Go or PHP or Ruby.
We need examples. We need documentation. I will put it on my tombstone. Tracy, here lies Tracy. She said documentation and examples are important. But absolutely, I won't take up time on this, and I promise, because I can go at length on that one. But if you don't understand something, we're not doing our job. So let us know what you need to make things better for everybody else that has to come and do the exact same thing.
And this invitation holds true for all the providers that are in there. Kube on its own has, what do we have here? Probably like 30 resources. I know other providers have even more. It can be hard to ensure that all the documentation is perfect. It's written by humans, so it will never be perfect because we all have different use cases, but any contribution is immensely valued. And so to get back to the question we had earlier about data sources, and my chat just popped away, so I don't know who asked that question directly, but if you head on over to the registry, click on documentation, you'll find a link to all the data sources. And for example, the namespace one, we looked at the service one, will describe what you can do with it. And here's actually a pretty nice example. In this case, we're consuming the example service and we're selecting it by name and taking its host name and using that for a DNS record in AWS Route 53, which makes this a lot easier to use. Even if you don't use Terraform to define your Kubernetes resources, you can still use it to define your DNS records. And let's see. I remember there was another question that we had. I think, does Terraform Kubernetes Provider replace kops? And if you haven't used kops before, it's Kubernetes Operations. I believe initially that actually used to be partially Terraform based in the backend. And it's definitely an interesting project. I find it hard to say that this tool is a perfect replacement, because as with everything, it comes down to what your workflow is. Are you more interested in a YAML-based workflow? Then you're definitely going to have more of a hurdle if you're doing everything through Terraform. Maybe you've already got all the knowledge that you need to do things with the kops way. Then that's, only change when it makes sense to you. I think from a technical perspective, anything that helps you get a production-grade cluster up and running that meets your organization's needs is the right tool. Now, if you do this through Terraform and you end up doing this on one of the big clouds, there's a handful of modules available for that. I know at least the big 3 clouds provide very, very decent modules with tons of options. I remember, I think in summer, what was the one we used, Tracy? I think that was the GKE one, right? with probably 100 different configuration options. So don't necessarily try to reinvent the wheel unless you really want to. Phil, do you have any thoughts on kops?
Yeah, definitely. So I want to be very clear that the Terraform Kubernetes provider cannot replace kops, because the Terraform Kubernetes provider exclusively manages resources inside the cluster, whereas kops is a cluster provisioner. So Terraform can, in theory, Terraform at large could replace kops if you had a reason to get rid of kops, because it can provision the clusters for you. And then you can use the Kubernetes provider to configure the cluster once it's provisioned. So it would be a combination of multiple providers. And there may actually be a kops provider out there. It wouldn't be HashiCorp managed, but there may be one that the community has submitted if you wanted to incorporate that workflow, into your Terraform configuration. I can't, if there is, I can't obviously vouch for, how good it is or anything like that. But that is sort of I guess the magic of the Terraform registry, right? Is that, there's a lot of things that may be surprising to you that somebody has already brought into Terraform for you to use and leverage.
I think that's also what's interesting. Building a module is very easy. And I think we have a couple of Twitch sessions planned around building modules and contributing back. And it also helps us understand how you use Terraform on your own, in your team, in your organization. Because a module is nothing more than a recipe that says, hey, this is how I bake my cake. And you might be using different amounts of ingredients than other people do. Maybe your IAM is deny, by default. Maybe you're actually like, allow everything and only block out specific parts. That'd be an interesting conversation to have. With modules, you can build your own things, especially if you look at the providers that we have. As Phil mentioned, you could use, let's say you're doing this on AWS, get the AWS provider, the Kube provider. You probably want Helm in there. Add whatever else is needed and go from there. So let's see. What other questions do we have at this point?
Someone wanted to know if we had any plans for running a HashiStack demo anytime soon. And so we don't actually have a session planned for that, but my very absolutely awesome teammate, Rosemary, has a demo for that. And the link to that repo is in the chat. So definitely go check that out. I see someone has decided to say a HashiCorp Live on Twitch would be a good way to explore that. So maybe that will be coming up soon. We'll have to see.
I think that would definitely be an interesting way of doing this, right? It's one of those projects where, hey, okay, so I want to deploy some compute and maybe I should have a good image for that. So let's use Packer to build something, have Terraform deploy your resources, bring in Console for some last minute and dynamic configuration, Nomad to run your application, make sure it runs nicely with Waypoint, get some credentials. I think, yeah, this is definitely a couple of nice HashiCorp Live sessions.
You're like a big kid with a play computer. Oh, and before I forget, because you were talking about modules, HashiCorp Ambassador Anton and Thierno, which is the main maintainer of the EKS module, they'll have a live stream talking about Terraform AWS, about the Terraform AWS EKS. I cannot speak anymore, coffee module on Anton's channel on YouTube. And I'll put a link to that. I think that's going to be really awesome. Let me see if I can find the link.
Yeah, if you're just joining us for the first time, and if you're generally not in the HashiCorp community and as an active participant, I would highly recommend checking out our Discuss forum, checking out what people talk about on YouTube. We organize community events like Hashi Talks. We just had one. We are actually currently having one in Latin America. We've got Brazil and Germany, Austria, Switzerland coming up. We've got a couple more planned for next year, including a 24-hour and 30-minute marathon, which is going to be interesting because, nearly 50 half-hour sessions of Terraform content HashiCorp content. Personally, I wouldn't mind if it were all Terraform content, but we try to do everything and give all the tools equal airtime. And it's a welcoming community. So let's see what else we have in terms of questions. I'm just reading this one. Terraform, Ansible, and Kubespray. Yeah, I can see how these tools work really well together. So Von Now had I'm really hoping I'm pronouncing your name sort of correctly. If not, apologies. Building these things together, even if you're deploying your cluster locally and not using something that's managed, I think that's the power of Terraform.
Yeah.
And so Web4 security. Yeah, am I missing the context for the Web4 security question here? Probably, yeah. Well, let's see. In the meantime, well, we've got 13 minutes left. Phil, why don't we talk a little bit about the operator?
Yeah, before we get there, actually, I'd like to double back a little bit and talk about the AlphaProvider again, if you don't mind, Kerim.
Absolutely.
So we touched on that a little bit, but we didn't really get to touch on where we're going with that. And I think that there's a lot of people that have been waiting for the AlphaProvider to mature and to become available. And as Kerim said, it's still in experimental status. I will say that, behind the scenes, we're doing a migration to the new Terraform SDK. And this is going to bring a lot of stability to the provider and close a lot of the gaps that we have today. In the medium term, and we're hoping, this will be very soon. I can't provide a date yet, but we actually plan on merging that Kubernetes manifest resource that you saw in the AlphaProvider into the Kubernetes provider itself, and then deprecating the AlphaProvider. So we don't intend the AlphaProvider to ever be a standalone provider, at least post the experimental stage. It won't actually graduate and become, GA or anything like that. By going GA, it'll actually be deprecated and that resource will be moved into the Kubernetes provider. So I think that's pretty exciting because we'll have one Kubernetes provider that will give you the clean UX of the well-defined resources, but also allow you to break out in that same provider to do anything, to include like managed nodes or whatever is available in the API using that Kubernetes manifest resource. So that was a question nobody asked, but I wanted to go ahead and put it out there. Do you have anything to add to that, Kerim, before we move on to the operator?
Yeah, actually, the alpha concept of having a separate provider for alphas and betas, we've had that with the Google provider. It's generally an easy way of testing something upcoming without having to necessarily rewrite everything from scratch. And it's a nice way. And once we know that things are stable enough, or stable, let's just call it stable, we'll move them to the mainline provider, and that's it.
Yeah, I want to be clear, it's not stable enough. It's definitely stable. That's what we're going for before we move
it definitely has to be stable, yes.
That's great though. Cool, and then the other project that we're not unfortunately going to get to demo today due to time constraints, but we have a Terraform Cloud operator for Kubernetes. And so what this allows you to do, and there are actually several other demonstrations that we've done. You can find them on YouTube. We've had some partners do demonstrations with it as well. One was at the last HashiCon. So I would encourage you to look at that if you're interested. But what this allows you to do is it installs a controller and a custom resource definition in your cluster, in your namespace. And you can, with your Kubernetes app, define a custom resource that will trigger a run of your Terraform code in Terraform Cloud, and then go through any policy checks that you may have in Terraform Cloud or Terraform Enterprise for that matter. It's compatible with both. And ultimately apply it. And then whatever you have set as the outputs, it will return back into Kubernetes today as a config map, tomorrow as a secret, so that your application can consume that And the things that may be returned, like let's say you're provisioning a database that's external to your Kubernetes cluster for your application to access, right? So it'll return the URL and the credentials for your application to access that. And then you just define in your deployment that that is an environment or an environmental variable from this secret or config map, and then your application can consume it. So it's pretty cool, right? So you can provision external resources to the Kubernetes cluster by interacting with the Kubernetes control plane, so you never have to leave Kubernetes. You get all the great things about Terraform. You get the graph dependencies, so it knows like what to provision when if you've got multiple resources. Right? It's really a shortcut, and what I find is folks are using this to really like supplant some of the more complicated pipelines that they've been creating. So if you have a continuous deployment for Kubernetes, you just define we call it a workspace resource. You define your workspace resource in YAML with your deployment, and then you can version your infrastructure essentially with your application without having to do anything else, anything external, right? Kubernetes, Terraform Cloud takes care of all of it for you. And it's not opinionated, right? So if you want to use YAML in your workflow, that's fine. If you want to use, the Kubernetes AlphaProvider, that's something, and obviously it'll be available in the Kubernetes provider here shortly, that you could use that for your workflow as well. And not only, of course, can you deploy, resources that are external to Kubernetes, but if you provide the proper authentication, you can do this for resources within Kubernetes as well. So if you have dependent resources that are created within Kubernetes. Maybe you want to create your database within Kubernetes, but you want to still do that with Terraform. You can use the operator for that as well. So it's really a pretty powerful tool. Falls in line, I guess, with the GitOps workflow. If that's something that you're transitioning into or have adopted, I would definitely encourage you to check it out.
Yeah, and I think we shared a link for the Terraform Cloud Operator in the chat. It's probably the best and easiest way to get started. There's a lot to demo with that, so doing it in 5 minutes time would not be actually the best possible demo because there's a lot of cool stuff that happens with it. But it is pretty rewarding seeing, your kubectl apply, work out, and then Terraform Cloud running your resources and just making sure everything works.
Yeah, one thing I do want to point out is, Terraform Cloud is a paid-for service, but there is a free tier. If this is something that interests you, you could sign up for the free tier. You can install the operator. You can try it out. You don't have to talk to anyone. You don't have to tell anyone what you're doing. At least on HashiCorp's end, in your enterprise, you may want to, tell other people what you're doing. But it's there for you to try self-serve and to enable self-serve for others within your group.
Thank you. That was a beautiful explanation of how the operator works. So with that, we have a couple minutes left. Now is your time to ask questions, anything that's Kube related, but we'll also try to answer any other questions that you have on HashiCorp's products. And while we wait, we have a couple more sessions coming up for you. So if Terraform isn't your thing and you'd rather hear about Console, then I believe we have at least 2 more sessions on that, 2 more deep dives. And let me see, I think I have a list somewhere.
I think Nomad is this evening.
Nomad is this evening, yeah, that's one. I think that was the event session, events in HashiCorp Nomad. We've got multi-cluster service mesh with Console, and I think monolith to microservice with Console and Kube. And as we mentioned before,
go on.
Thank you. Once KubeCon is over tomorrow, HashiCorp Live, where Tracy and our guests will show you how to use the Terraform SDK, so you too can build an awesome Terraform provider. And people always ask, like, hey, what's your favorite provider? For me, it's not the Domino's Pizza one because that doesn't work in Europe. But I know a lot of my love those. So, if you want to provision pizza, Terraform got your dinner coming right up.
So horrible. So horrible. But yeah, we got tons of stuff coming up. Link to the community office hours is in the chat. This is not a, we do these all the time. So don't just come here because of KubeCon. Come visit us all the time on our office hours. We got a lot of those lined up. HashiCorp Live tomorrow on provider development, the who's, the how's, the why's, the what's, and what's better and what hasn't changed. Anton's live stream, that's also in the chat. Please go visit. And you can see what our HashiCorp ambassadors can do, because they are an awesome and interesting group. They are. But other than that, come join us in the KubeCon chat. So there's a link to that in the chat as well. So check out the back scroll and come see what we're talking about, and you can ask us questions there also.
Yeah, we're our channel name is 6-KubeCon-HashiCorp. So find us there and let us know what questions you have. And so we've got 4 minutes left. So while we wait for some more questions, if you're just joining us, you're about 57 minutes late to learn about cool Cube stuff, but that's okay. We will upload this on YouTube so you can watch it later. But one of the things that you might want to hear about, code quality for Terraform. If you're coming from a YAML workflow, if HCL is new to you, that's okay. It's the kind of language that you can pick up and learn in probably 2 hours, and then use for Terraform, Vault, Packer, with the new Packer anyway, Console, and all of our other tools. And you might wonder, how do I make sure my code is good? Well, first of all, less repetition is always good. We'll actually share a link on some code quality thoughts with you. But Terraform makes it really easy to write good code. Built-in tools, Terraform FMT format, which you might know from Go FMT, FMT, as some people like to call it, and Terraform Validate help you make sure that any code that you want to use is actually valid. Doesn't necessarily make a statement on if it's good, because that always depends on what your team requires. And yes, FMT is definitely the right pronunciation for that.
It's right up there with kubectl, which is the proper way to say that.
Oh,
I appreciate Phil for saying that earlier. It's a cuddle.
It definitely is.
Yes, the warm embrace of Kube.
Oh, this is beautiful.
Yeah, I would like to just interject real quick and say, as the product manager for these tools that you saw today, I would love to hear from you, not only in the issues, right, or in the Slack channels, but if you go to the repos and you have feedback that you want to deliver, you can actually find a link to put some time on my calendar. And I would love to hear what's working, what's not working, your use cases, your workflows. I'm here, to listen to you, and I would love it if you did reach out to me.
And your feedback actually ends up with real people like Phil, who are then able to do something with it. And I think that's what makes these tools a joy to use and much more personal. And so on that positive note, the warm embrace of Kube and the loving hug Terraform can give you, thank you for joining us today. It's been an absolute pleasure. As Tracy said, make sure to check out our community office hours. We do these multiple times a week for different tools, and we'll see you at the next one.